Let's look at questions from the second exercise now. 18th. A, B and C can do a job in 15 days. After working with B and C for 5 days, A leaves. Then B and C finish it in 20 days more. In how many days can A do the job alone? Let us look at this question in two different ways. Okay. Let me take the easier or the simpler method first, but obviously that will be a little time consuming. Let me assume the quantity of work, okay, or the amount of work. Let me assume the amount of work to be LCM of 15, 5 and 20. These are the 3 days which are mentioned. So let me look at a number which is a multiple of all 3. So let me say the amount of work or quantity of work is 60 units. Okay. Now A, B and C can finish the piece of work in 15 days, which means they will do 4 units per day. Okay. So after working with B and C for 5 days, so A, B, C work together for 5 days. Or in other words, in these 5 days they will do 20 units of work. But the total amount of work was 60 units. So the amount of work which is to be done by the other two alone is 40 units. Okay. This implies that in 20 days B and C will be able to do 40 units of work, or B plus C will do 2 units per day. 40 units in 20 days, it is 2 units per day. So now we know that A, B and C working together are able to do 4 units per day, while B and C working together are able to do 2 units per day, which implies that A working alone will do 2 units per day. Since the amount of work is 60 units, A is able to do 2 units per day. That means the number of days taken by A to complete the work alone is going to be 30 days. This is one simple way of solving this question, but this question could have been done much faster if you just get back to the basic concepts of ratios. Let me just erase the slide and create space for working. Okay, yeah. Now let's look at the question again. A, B and C they can do the piece of work in 15 days. So that means in 5 days A, B and C will be able to do 1/3 of the work, because they work together for 5 days. So in the 5 days when they are working, they have finished 1/3 of the work. So the remaining work, which is 2/3, has been done by B and C in 20 days. So if 2/3 of the work is taking B and C 20 days, that means the complete work, total work, will be done by B and C in 30 days. So B and C are together able to do the work in 30 days. A, B and C take 15 days to complete the work. This implies A alone will take 30 days to complete the work. Okay. So this could have been easier and faster, but obviously this assumes you are comfortable with fractions and reciprocals. If you are not, then the first one is a better way. Even if you are not very comfortable, you could have started from here. It's like saying B and C are able to do the piece of work in 20 days. A, B and C do the piece of work in 15 days. Let me assume A does piece of work in X days. So then you could have said X into 30 upon 30 plus X is equal to 15, which implies 30X is equal to 450 plus 15X, or X is equal to 30. So you could have then used this formula. What is this formula? If 2 people are there, one person can do a piece of work in X days, another person can do a piece of work in Y days, the same piece of work in Y days, then working together they will complete the work in X upon Y, X into Y upon X plus Y days. If the same piece of work can be finished by first person in X days, second person in Y days, then the number of days required for both of them to be working together to complete the work will be xy upon x plus y. That's the simple formula that we have applied here.